Hi you guys, we're doing 8.2 vectors in the coordinate plane, and this is day one, and I think you will find day one to be pretty easy. It's just really learning what the vocab means so you know what you're supposed to do. And then day two will be a little bit more difficult, so leave yourself some time to do that lesson. So our objective for today is to represent and operate with vectors in the coordinate plane, and component form is our vocab, but we actually already did that last time when we found the horizontal and the vertical distance um, of a vector or a force. So this says the component form of vector AB with initial point A and B is given by, and you will see that this is just the same formula as the distance horizontally for x and as the distance horizontally or vertically for y. So let's do a couple of these problems. Find the component form of vector AB with initial point A of 1, -3 and terminal point B, 1, 3. So I'm just going to go and I'm going to take the difference of my x's and the difference of my y's, and that will be, so my x's, I'll just take 1 minus 1. Oh, I need a pen. Those are my x's. And then I have 3 minus a -3. So my component form of this vector is going to be 0, 6. One B will do the same way. We'll just take the difference of our x's, which is going to be 6 minus a -2, or 8, and 1 minus a -7, or 8. Then we're going to talk about magnitude. And magnitude is the same thing as the length. And as you can see, when you put things into a right triangle like this, it's the same thing as the hypotenuse. And that'll be represented by the formula here is just like the distance formula, and this formula here is just like your Pythagorean theorem. So this is nothing new, just different wording. So if you already have the component form, you can just use this. Otherwise, you can use the distance formula. And really, if I just find the component form, then I just plug it into this Pythagorean theorem looking thing. One thing to note is magnitude looks like, has these kind of absolute value bars around it. Okay, so that's the magnitude of vector V right there. So, which makes sense. Absolute value makes sense, right? Because distance is going to always be positive anyway. So let's find the magnitude of vector AB. We actually already did the component form of this one. So the component form of this one was 1 minus 1 is 0, 3 minus a -3 is 6. And now we just need to put it into this Pythagorean theorem. Okay? So we have the square root of 0 squared plus 6 squared, which is the square root of 36, which is 6. Okay, so the magnitude of vector AB is 6, and I'll write that out. So you can kind of see that. Oh, that's interesting. I hate when it does that. We'll do one more for fun. So I'm going to find the component form, and then I'll just put it into this formula. So I have -3 minus 4, so I have -7, and I have -2 minus a -2, so I have 0. And again, I'll put it into my little Pythagorean, so I have -7 squared plus 0 squared gives me the square root of 49, which is going to be positive 7. So the magnitude of this vector AB is 7. The last thing we'll talk about are vector operations. And basically it's just how to add them, subtract them, and scalar multiplication. So it's actually very similar to like how we do matrices. Okay, you're just adding the kind of the x's and the y's together. So let's do this one, 2w plus y, and here's our w, here's our y. Okay. So 2 times w, so I'm going to write 2, am I going to write that? 2 times vector w plus vector y. So 2 times 2 is 4. 2 times -5 is -10. And then I'm going to add it to that 2, 0. And I get 6 because 4 plus 2 is 6, and I get -10. Okay, so 2w plus y is 6, -10 in component form. We'll do this one too. 3 times y, so I'm going to have 3 times vector y minus 2 times vector z. So this is 6, 0 minus, actually I'll just make that into a plus, 2 and 8. So that gives me 8, 8. I'd like to point out, I guess, if I flip back to the magnitude, I know these ones, they worked out nicely, so you had whole numbers, 6 and 7, but you may end up with decimals and stuff, so don't be surprised if that happens. I think you'll be fine on your assignment. Let me know if you have any questions, but these are the first, very similar to the first 3 examples in your book. So have a wonderful day.